And so with those preliminaries, I'd like to introduce our tonight's speaker. I never get to introduce tonight's speaker because usually I'm in the audience if she's speaking. But we all know how valuable she is here at Rice and what a great scientist she is and all the contributions she's made both in the science and the education. And so it is something to actually then just pull the bio and have a look at it. And I don't have the time to read it all, but I'm going to pick some of the highlights of Pat's career and all the amazing things she's done. And for me, I'll mention one of the important things right at the end. So tonight's speaker is Professor Patricia Reiff. She's been involved in space plasma physics research for more than 45 years, with interest in magnetospheric convection, plasma particle acceleration mechanisms, and solar wind control of the magnetosphere and ionosphere. She got her PhD here at Rice, analysing Apollo plasma data back in the day. She's a co-I in many different missions, including the Dynamics Explorer, Polar, Image, and the cluster missions, and in particular, she's the EPO lead for a very exciting mission called Magnetospheric Multiscale, which is a four satellite mission. On the education side, she's developed a number of products that are educational and used by many people. Space Update software has been used by over 1 million visitors in 15 museums around the world. And the Earth Update and Space Weather products have been distributed to 400,000 educators and learners. The Immersive Earth project, which she built in cooperation with the Houston Museum of Natural Sciences, which is a full dome digital planetarium show teaching Earth science, basically through the Planetarium System Discovery Dome. I think it's 300 sites in 33 different countries and 33 states. These projects have led to a couple of companies, Space Update and ePlanetarium. And that's just what she does like in her spare time. She has over 150 refereed publications. She's acted for her community in the form of being an editor and an associate editor for a couple of different journals. She's on advisory committees for NSF, for NASA, National Academy of Science, and so on, including being on an education MOOC for NASA, which is a management operations working group, which is an advisory structure to NASA. She's chair of the Council of the Institutions of University Space Research Association and serves on the SPA Public Education Committee for the AGU. And remember, I'm only reading out some of the highlights. She was elected a Fellow of the American Geophysical Union in 1997 and received the Athelstan Spillhouse Award for Public Education in 2009 and the Spark Award in 2013. Also, for me, one of the most important things, apart from being one of the people who hired me here at Rice a long time ago, Pat also is the founding director of the Rice Space Institute, which was founded in 2000. So we missed our 20th anniversary. We were going to try and do RSI turns 21, but COVID has other ideas, so we may end up doing 22. We'll see. But RSI was a great part of Rice and allows us to talk more broadly about space. I was honoured to take over the role as the director in 2012 after Pat had served 10 years. Still doing lots and lots of work in the public outreach side and so on. And we are here today in part because of Pat's vision back in 2000. So please join me in welcoming tonight's speaker, Professor Patricia Reiff.
Great to be here, and one of the nice things about the present protocols is if you are the professor and you're more than 10 feet away from your closest person, you can take off your mask. I can't, but I haven't moved it. But I'm vaccinated and I got a negative test yesterday, so I'm good. As good as you get these days. So David asked me to sort of give a little history of space science here at Rice, and although I've been at Rice in one form or another for now 50 years, that bio is a few years old, I need to fix it. The department actually started like 8 years before I showed up, so I wasn't here for all of it, but I knew the people who were. So I'm probably the longest lasting one who's still around and still working. So I want to talk just a little bit about the history of space at Rice, and it's been a lot of fun, and we've had some really amazing successes over the years, and some really astounding research and students that have gone through. I see somebody has chatted. I should probably open the chat to see what's up. With any further ado, I will move on.
So Pat, the only thing is you have that white background behind your bright background. If you open up the chat, you might just want to look for notifications.
That's a good point. I will not do that. So if there's a chat, somebody yell at me, okay?
Move your hand.
No,
not that.
Click the arrow, the little arrow at the top.
This arrow, okay.
And then close.
There you go. All right. That'll get a little darker behind me. It would be nice to have a spotlight of some sort. Okay, so anyway, not that.
I was impressing people with my skills and sending all this out.
Oh, actually, that's the one I wanted to get rid of anyway. Perfect. So I want to talk a little bit about the history of space science, and here are some websites where I got some of my information. The spacolum.rice.edu is our website where we post a lot of our history, and so a lot of the things that we've done are posted there. A lot of old pictures and some reference materials that you can find. Space.rice.edu is our outreach page for space sciences at Rice, and it has links to my Eclipse page, my Apollo page, my Reach for the Stars page, and other outreach pages that we've developed. The www.rice.edu/NASA has a bit of the history of space at Rice. It was developed for the 50th anniversary of Apollo. Scholarships.rice.edu, that's a really, really interesting and actually kind of scary thing, because you can go in and find anybody's thesis that's ever had a thesis from Rice that was microfilmed or digitized. You can find it there. You can find all the old campaniles, all the old threshers, and just for a lark, I started putting in my name and Don Clayton's name and Brian O'Brien's name, and I just got pages and pages of stuff. So and there's more material going in all the time. So if you ever want to see some source material, that is a great place to start. And then of course, history.nasa.gov. And then I want to thank all of the alumni who have been so good about sending me stuff when we ask for it. So I'm going to move over here. No, that's not going to work. Okay. Okay, so as I like to say, I'm a child of the space age. I was 7 when Sputnik flew, and it was certainly something that stunned us all. We knew airplanes, we knew jet planes, we knew that the Germans were shot rockets during World War II, and of course we had our German rocket scientists and their German rocket scientists were both in a race with Russia to see who could be the first to get a satellite in orbit around the Earth, who could be the first to get a human in orbit around the Earth, and basically Russia won both of those, and so that was a stunning thing for us who lived through that, and it really put the U.S. into high gear. We were, at that time, it was the International Geophysical Year, so there was a lot of research going on in the Aurora and in Earth's magnetism and in geophysics. And so there was a big solar maximum back in 1956. And so a lot of the early rockets flew during one of the most intense solar maximums that we'd had for the past 30 years. So after that, of course, we had the first human in space, and that was even more of a shock to us Americans who believed we could do everything sooner and better than the Russians. This is a mock-up of Gagarin's capsule, and mannequin at a Russian museum. But again, we all were shocked when Yuri went into space, and really disappointed, because we had tried very hard to beat the Russians. And if you notice the dates, we almost did. There was a couple of rockets that had to be redone and for safety's sake. And so we, in fact, didn't launch the first American 2 weeks later. I mean, this is only 2 weeks later, okay? April 12th to May 5th. But again, it was something that, you know, we're doing catch-up, you know. Yuri had already orbited, but Alan just did a suborbital flight, sort of not unlike the Branson flight. Whereas Yuri did multiple orbits, and so we didn't get our first orbits from space until John Glenn flew in February of 1962. So the US was playing catch up in space, and it really galvanized space education, and really galvanized STEM education. We didn't even know what STEM was back then, but we knew what it was that we needed to teach, and that was what we now call STEM. So that, again, John Glenn then became a huge hero, no surprise. And then, you know, what's the next things we're going to do? Well, the first communication satellites were launched. The Telstar was launched in 1962, and I remember my mom saying, let's go in the backyard and see Telstar and go over it. Because, you know, like most satellites, if you go early in the morning before dawn, or in the evening just after dusk, that's the best time to see satellites, because they're still in the sunlight and you're in dark. And we saw the Telstar going across, and it was very, very, very captivating for me. And the very first images relayed from space using the Telstar was this really fuzzy, out of sync, flippity, and barely legible video. But that was a video that had been bounced across the Atlantic Ocean from England, bouncing off the Telstar satellite. And really the beginning of all the communication satellites that have happened since then. Well, so even though Reiff didn't have a space science department until 1963, it had already started working with NASA. Jean-Claude de Brémacher had been doing some geological work. Reiff had been involved in some of the planning of the new Space Center, even before Kennedy's speech. So here was a setup that was on display at NASA. And if you look closely here, there's a map. And that map was a plan that had been hatched by two Reiff roommates as to a way to get Johnson Space Center to Houston, because they wanted Reiff to be a leader, and they wanted Houston to be a leader in space. And so George Brown, who was an engineer, and Congressman Albert Thomas were roommates at Rice University and graduated in 1920. And so they conflabbed with Kennedy and with the rest of Congress to try to figure out a way that we could secure the Johnson Space Center in Houston. And what they did, which was extremely clever, is they got Humble Oil to give to Rice the land that Johnson sits on, okay? Because Humble wouldn't get a tax write-off if they gave it to the government, but they would get a tax write-off if they gave it to Rice. So they gave it to Rice, and then Rice sold it to NASA for $20, but then also sold some other land for a little bit more. So we ended up doing okay from it. But you can actually see in that link, you can actually see the deed, which is kind of fun. And here, from that same display that I showed you, here's the map of the NASA Road 1, and look at all that land, it says Rice University. So that was in that golden 6 months when Rice University owned the land that became Johnson Space Center, right before it was turned around and sold back to NASA. Well, everybody knows then, of course, Kennedy came to the Rice campus on September 12th, and I was in 8th grade at the time, but I was extremely stirred by that because both my parents were medical doctors, and I thought I was probably going to go into medicine or maybe veterinary medicine because I love being outdoors. But you know, here was science, and it was really stimulating to me as a potential thing to study. And we have a few of the reprints of that speech, and I had intended to bring them, and I'm sorry I didn't. So if you want a copy of that, let me know, and I can get one for you. And so Rice really responded then to this speech and really got on the stick and said, what can we at Rice do to really make this happen, to make Johnson Space Center being the hub of manned space. And so the Office of Space Science Director, Newell, came to Rice campus and spoke, and we all got excited. I wasn't here back then, but the Rice got excited about participating in this venture. And if you listen to Kennedy's speech, and I really recommend you do, it's like an 18-minute speech. You can watch it on YouTube. It's really quite an excellent speech. But he, one of my favorite quotes from that is, why does man want to go to the moon? Why does Rice play Texas? And guess what? We're playing Texas this weekend. So I guess that means we're going to go back to the moon. But the most important thing is the president of Rice, Kenneth Pitzer, he said, okay, we're going to do it. Well, we will start the first space science department in the nation. So they kind of sent it to the board in January. The board approved it. And they hired Alex Dessler, who really came on board immediately. Oh, by the way, Pitzer also was the one who integrated Rice and doubled the size of the library. So he was somebody who really did an amazing job for Rice, and then he left us to go to Stanford. So anyway, he hired Alex Dessler to lead the new department, and Dessler went out. He, at the time, was at the Southwest Research facility, which is now the University of Texas at Dallas, but he was originally from Caltech, and so he went back and snarfed up some of his Caltech buddies to start the new department, and snarfed up good people from Iowa and everybody who he could to form the new department. And his vision is why we are where we are today. He had he was a theorist, but he had a pretty good head for experimental work as well. At least he knew where to get it. So he then brought he was introduced to the department. These are all clippings that were from the Sally Port or from the Thresher. And again, you can go on that scholarship.rice.edu and punch in Alex Dessler, and you'll get 800 pieces. So the first person he hired was Brian O'Brien, who he got from Iowa. Brian had been an engineer scientist in the engine group there, and with Van Allen, and so had a lot of experience in launching satellites, and so he was a natural to come to Rice. And oh yeah, some of these notes down here. One of the things that I've done is go through and do the science genealogies of the founders of the department. And Alex Dessler, if you look at who his thesis advisor was and his thesis advisor, you can go all the way back to Isaac Newton. With O'Brien, you can go back to Erwin Schrödinger, and then from there on back to Magnus, who was one of the first discoverers of magnetism. So it's kind of cool to be in the line of someone who discovered magnetism. So O'Brien went to work then and brought engineers and to get started with a rocket program here. NASA also paid for a new space science and technology building. So that was agreed on in 64, and I think it was finally finished completion in 66. They had their little explosion for the groundbreaking that was sent by a satellite signal, although I've heard that was actually bogus, but who knows. One of the things, because the basement had a big machine shop and was building large payloads, there's actually a big hole in the ground where a crane could lower large pieces of equipment from ground level down below where the construction was made. And it has a lip on that hits you about knee high. And when we had the floods of 1974 and 1976, the water level came up almost to the top of that. If it had gone another 2 inches higher, it would have completely flooded the basement. As it was, we got 3 or 4 feet of water in the basement and lost a lot of our data tapes from Apollo, unfortunately, that had been stored in the basement. Another experimentalist at the time that he hired was Bob Haymes, and he started off working with the rocket program here on campus, and then ended up working with balloon board payloads. Here's a picture of him and a technician putting together a payload. We had many really talented engineers and postdocs that helped with this facilities. That one is John McGarity there. This is Del Omi, who just passed away last week. Bob Ether was a postdoc here.
So Bob's on the line.
Huh?
Bob's on the line.
Bob's on the line? Wave. So that they helped, create the payloads and get them up and get them down. Here are some of the students that were very instrumental in working with these spacecraft missions. This is Jerry Fishman, who worked with Bob Haymes on the Gamma Ray Telescope and now is the head, just retired as being the head of the Gamma Ray group at Marshall Space Flight Center, and got the Shaw Prize from Japan for his groundbreaking work on gamma ray satellites. This is one of the rocket payloads. Again, here's Del Omi again. This is a very young Paul Cloutier, if some of you know Paul. Dark hair. It looks like he was in high school at the time. But that was really important to get the students involved. And one of the students that O'Brien got involved was a guy named Dave Reasoner, and Dave Reasoner turned out to be my advisor. So Brian O'Brien is my science grandfather. And so they got, again, NASA grants. There were several satellites that were flown, 2 in the Sammy group and 1 that was called Aurora 1. But then and this is Jim Burch, again, a very young Jim Burch, and the Aurora 1 payload. Again, Jim Burch is now an amazing, the head of the Space Science Group at Southwest Research Institute in San Antonio, and was just named this week the Bowie Medalist for AGU. So we're very proud of all of his accomplishments. But unfortunately, the OWL satellites got canceled. There was some politics involved. There was a little bit of overrun in time and in money. And of course, if you're an astronomer, an overrun in time and money is nothing. But if you're a space physicist, you better be on your toes. So So unfortunately, those satellites, which were really well ahead of their time, they were going to fly two in tandem to unfold temporal and spatial understanding of the Aurora. As I said, unfortunately, those satellites got canceled, and here's again a picture of the Aurora payload, again with O'Brien and the staff there. Well, O'Brien, as you can maybe tell from some of the body language, he got a little aggravated with Reiff that they weren't sufficiently backing him up on this OWL satellite business. And so anyway, he went back to Australia and left Reasoner in charge of some of his work here at Reiff. Which was a shame because O'Brien was really amazing guy, but there's always a little tension between the theorist and the experimentalist, I can tell you. But we did have some theorists, and we had some really amazing, fantastic theorists. Here's a very young Don Clayton, who we got from Caltech, and he, as I said, he literally wrote the book on the nucleosynthesis, the synthesis of heavy elements, both inside stars and as a function of explosions such as supernovas. And in taking the isotope ratios in meteorites and using that to estimate the age of the meteorite, and also at the same time estimate the age of the solar system. And he found some meteorites that were actually much older than the age of the solar system itself. Another amazing astrophysicist was Kurt Michael, who also literally wrote the book on pulsar magnetospheres, how a pulsar's magnetic field allows the pulsar to go beep, 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 and get the energy from its spin down. Kurt was chosen as one of the first scientist astronauts of NASA, but this was really kind of at the end of Apollo. They canceled the last two Apollo flights, and so he kind of looked around and he said, it's going to be years before I fly, so I'm going to go back to Reiff and go back to being a scientist. So he retired from the astronaut program and came back and picked back up his research work. But both of them, for their amazing work, got honored by having endowed chairs. And so this is Don and Kurt. And this, again, is a very young Frank Jones, who's still teaching here at Reiff after 60 years. And this is that was Bill Gordon, who was the father of the Arecibo telescope and came to Reiff as a dean, but he did all of his research work in the space science department. So all of his 12 graduate students were in our department. Another fun topic that we studied here at Reiff was thunder and lightning. Alex got a grant to do that, and he took on a graduate student, Art Few, and his research basically discovered that most of lightning in clouds is not ground, top cloud to ground, but within the cloud, lightning. And his thesis was named just Thunder, which you gotta admit, that's, you got a classic name for your thesis. So of that first group of 1960s students, all of them went, and I didn't even name them all of them went on to really distinguished careers. Only Art Few and Paul Cloutier stayed at Reiff. The rest went on to other locations, mostly at NASA or at Los Alamos or at science companies. So Another early faculty member was Ron Stebbings, who came over from England, and amazing, nice guy, just one of the nicest people you've ever met, and also one of the smartest. And his work was to study atomic collisions and to really get what we call cross sections. How likely is it that one particle hitting another particle will strip away one of the electrons? And we call that a charge exchange reaction. And I always thought it was kind of arcane, but when I started doing the image spacecraft 20 years later, we actually used that process to look at energetic neutrals coming from the outer edge of the heliosphere. And his laboratory measurements made accurate determinations of what those fluxes really mean as far as the source populations by doing that, those complicated measurements. And here are some of his students, including astronaut Jim Newman and Barry Dunning, who he brought over as a postdoc and is still working with us today. He became the second chair of the department, by the way, and then became, he was the magister of Jones College, and then became dean of students because he was just so amazingly exciting. So here's what the faculty kind of looked like when I arrived in 1971, and I got accepted in both the physics department and in the space science department. And, you know, I visited them both, and the physics department were all 60 years old, and these guys were all 30 years old. I have an easy decision here. But more importantly, I said, you know, I got accepted for September, but my then husband was in the Army going to do his basic training because he wanted to stay out of Vietnam. And so he was going to go do basic training and get into the reserves so he wouldn't have to go to Vietnam. And so I had a summer basically free. I'd done what was like an REU the previous summer at Argonne National Lab. And I can tell you, I spent that whole summer in a lab doing low temperature measurements of helium, and my whole summer was waiting for the system to settle down because we wanted to take these measurements to 12 significant digits because they were trying to do second derivatives of temperature and pressure of helium-3 right at the triple point. And so you had 6 degrees of 6 digits Wheatstone bridge and another 6 digits Wheatstone bridge, and you had to balance them. And so I spent my whole day waiting for the equipment to settle down so I could take one data point a day. And I said, I'm not doing that again. You know, I think one of the really important things of doing these summer research programs is not only that you see what you want to do, it's you see what you don't want to do. And that was something I just said, I don't want to do anything to 12 significant figures again. I want to go someplace where we don't know anything. I want to learn the first significant digit of something rather than get the 12th significant digit of something. So when I then, after I'd been accepted to both of them, I said, well, who's got a summer job? Because I don't have anything to do, and I might as well come to Houston, because, you know. And they said, well, we just put an experiment on the moon on Apollo 14, and we need a computer programmer, and do you know Fortran? And I said, yeah. And he says, well, do you know assembly language? And I went, no, but I'm a quick study. And so I got hired to be a computer programmer that summer before I started graduate school, and that really made a huge difference because I got a whole semester's worth of research done that summer before I started graduate school, and it really made me finish in 4 years, which a lot of people weren't able to do. And so here I was, and this is what computers looked like back then. I hate to tell you, with the big 7-track, 9-track tape drives and big wide printouts and data coming out chunk. These were actually at the Johnson Space Center at the ALSEP room where we were looking at real-time data from the moon. Normally we didn't do real-time data. We'd get the data tapes back and we'd look at them later. But this was when there was the Apollo 15 was coming in, and as Apollo 15 came in, the rocket body hit the lunar surface and kicked up a bunch of dust. And so we were analyzing the data to see if we could see the electron cloud from that impact. And so we were watching the data chunk coming in, and sure enough, it was there. You could see the electrons that got kicked off from that impact. And when people say, you know, the moon missions were faked, I'm going, nobody was sitting back making up this data. You know? It would have been so difficult for them to invent data that just happened to be right. Just doesn't make any sense whatsoever. And one of the really cool things about the instruments that we at Reiff had on the moon is they're pretty primitive by today's standards, but we discovered things that have been confirmed later on with much better instruments, and so it really made us feel like we were on the right track, and which also made me say, if anybody says, you know, we didn't go to the moon, I might not sock them, but I certainly wouldn't agree with them. So I was working with Apollo 14, but that was not the only instruments that Reiff had on the moon. The Sallyport, for example, when we did the lunar landings, the headline, of course, is Reiff beats A&M. So if you want to see about Reiff landing on the moon, that's actually inside. There it is. And so it talks about, hey, we made it there and all the instruments that were there. And as I said, this was really a lot of fun poking around the Woodson archives. So the very first instrument that we had on the moon was the dust detector. Again, it was a Brian O'Brien instrument. And for the first Apollo 11, they really didn't have what we call an ALSEP, Apollo Lunar Surface Environment Package. They really just had a very minimal number of experiments just to make sure that everything worked. I mean, the primary reason for Apollo 11 is to get there and get back safely. And then the other Apollos really had more of a science thrust, but even so, it was mostly to say we did it. But there was a big concern of whether there was how much dust there was on the lunar surface. There was a concern whether when they landed they just sink down into oblivion. But fortunately, the dust, even though it's very, very pervasive, it was certainly good enough to walk in. But the problem with the lunar dust, because of the static electric buildup, that dust gets everywhere. And in fact, you can almost see it on his boots here. That all of the astronauts coming back from the moon said, you know, their suits were just covered with dust and really sticky because of the electric charge. And so this little dust detector had basically 3 photometers, and it measured the output of the sun through these 3 photometers. And one of them, as the sunrise, you know, showed no, here's where it took off. And it didn't really show any decline in light intensity on that detector. But this one showed a jump, and this one showed a tremendous jump. So what that said is, as that Apollo 11 took off, it kicked up some dust that then covered up those solar cells. So it was a very simple instrument. It was just solar cells that you measure the output of. But when the output goes down, you know they're covered with dust. So they had a similar one on Apollo 12. And again, you can actually see some of the moon dust that's on the instrument itself. The Apollo 12 also had the first of the side instruments, the super thermal ion detector instruments that were done by John Freeman, also from Iowa. And this was an ion detector, but it also had a ion, it could also tell the ion mass, so you could tell oxygen from hydrogen. And the idea was just to look to see if there's any naturally occurring atmosphere there, or anything that gets kicked up either by solar wind impact or other impact. And you notice it's got a lot of spider web at the bottom. That's to give it a good ground itself with the surface. And of course, the side instrument had quite a number of outstanding students that finished their PhD working on side. I was working with CPLEE, which was, you know, O'Brien's sort of last experiment before he left. It had been planned for both Apollo 13 and 14. Of course, all of you who've seen any movies or been awake in the last 4 years know that Apollo 13 didn't make it. And so the first CPLEE instrument is, you know, somewhere out in space someplace, but it's certainly not on the lunar surface. But Apollo 14 did, and it was placed on the surface and took very good data. It had both an electron and an ion spectrometer that had two look directions, looking up and looking to the side. So we could tell the difference between precipitating particles and particles, you know, bouncing along the surface. And so that was the instrument that I worked on for my PhD. And meanwhile, the rest of the departments were doing fun stuff too. Anderson and Cloutier continued the rocket program, and Haymes, after doing some rockets, then went into flying gamma ray balloons, both in Palestine, Texas, and also in South America, where they discovered the gamma ray fluxes from the center of the galaxy, which is the very first gamma rays in space from electron-positron annihilation. And then Bill Gordon's group used the dish at Arecibo to study both the Earth's ionosphere and for astrophysical measurements as well. Here's an old picture of Arecibo where you see this horn was sort of a later addition. The original horn was much smaller. This is an article written by Rich Binky in 1972 as a history of what Reiff has done in science. And this arm, it's hard to see this arm, but that's the arm that they use to launch the balloons. So when you're launching a balloon and the balloon's going up, you don't want to have your payload bouncing along the ground as the balloon is going up. So there's actually a lifting arm that lifts it up so that the payload gets off the ground without bouncing, because that's no fun. I think that was called Tiny Tim. We had some really amazing space physics theorists, including Dessler, of course, but also Dick Wolf. He taught me. He was assistant chairman when I came in as a graduate student, and his gentle demeanor and self-deprecating humor always very much endearing to me. But he taught the basic fundamental plasma physics class, which was extremely well organized and well taught. And my grader just happened to be a theorist student of Alex Dessler's called Tom Hill. And I thought he was pretty insufferable at the time. But fortunately, I made a good grade. So. Well, interestingly, and again, one of those things, when Tom was taking a lab course in physics, Jim Burch was his grader. So we were definitely incestuous. I mean, that's one of the things the graduate students do, is they grade papers for the faculty members, and it's part of their training. But it's also a great way to meet people, and That's how I met my future husband was, well, by 1974, when they cut the last two lunar landings, they also said, well, you know, those experiments on the moon, those were really mostly for show, you know, who needs to pay for those anymore? So they started really cutting back on the money that we had for analysis. And so it was kind of, you better finish now or you're not going to finish. And so that's the other reason why I finished in 4 years. I cranked myself up and got done. And Briesner was not on the tenure track faculty. He was an adjunct faculty member, and so he kind of saw the handwriting on the wall, and he went to Marshall Space Flight Center in Alabama and started working there. So in fact, my last year graduate student, my advisor was in Alabama, and I was here, and it was great because I got a lot done. But then when I finished, I went to Alabama also on a postdoc, and when I was there at a postdoc, Tom went to a postdoc in Boulder, Colorado, and so it was kind of those things that you had to get married, you had to get apart. So we thought, well, we'll cool off for a while. And I went to Marshall, and he went to Boulder, and I again started working with Jim Burch, and that's a colleague that I've now been working with for more than 45 years. So he was working on an detector in space called Atmosphere Explorer, and I started doing analysis on Atmosphere Explorer with Jim. And then after my postdoc and Tom's postdoc, we both came back to Houston and got married here in the Rice Chapel, not far away, on the bicentennial, which is why we're dressed up in red, white, and blue. It's a great way to remember your wedding anniversary is the 4th of July of '76. And the guy who married us was the brother of another Rice graduate student. In fact, the very first space science PhD from our department, who was one of Alex Dessler's students. Pitzer's brother. So about that time in the mid-'70s, Reggie Dufour joined the faculty. Barry Dunning joined the faculty. He's still pretty young, pretty exciting group. There's Art Few there, Bob Haymes, and again, the next group of graduate students in the 70s and early 80s were really a spectacular group of students. In 1977, because of money and also because the radioactive power sources for the lunar experiments were dying down, they shut down the last experiments on the moon. And they invited us all that were still around to actually see the last experiments on the moon being shut down. And this sign was up on the Sept room. It was there for, they created it for a demo to Congress. But it had been in the Sept room for the whole time since Apollo 11. And so as we were turning off the last experiments on the moon, they sent the switch to turn off the instrument that I had been working on, CPLEE. And I stood over the guy and said, gosh, that was my experiment. I wish I could have done that. I wish I could have turned that one off. And he said, well, you can turn off the last one. I said, what is it? He said, the seismometer. I said, oh, okay. So I actually got to flip the switch to turn off the last US experiment on the moon. Now there's been some Chinese ones now since then, but at the time that was the last live data from the moon from 1977 till just a couple of years ago. There has not been live data from the moon. So we all signed it, and I got to keep the sign. So this sign is in my office. Tom and I both taught and did research, but we also decided to have some kids. So here I am pregnant with our first one. check out the computers. I mean, one of this is a great story of the history of personal computers too. So we had one baby, and then we had two more. And in fact, we had twins, and at the same time, two other in our department had twins too. In fact, Maria's here. So these two are mine, and that's with my nanny. Okay, this gal had two. Oops, come back. This Sally, she was a secretary. She had two. So I think this one's one of hers, and
I think I had another baby.
Tamara?
No, Norma is holding.
Norma's holding her other one.
Yeah.
Yeah,
And
see
then
the
I have
size.
the little one.
The
Maria's,
size, yeah.
oh wait, Maria's not holding any of her children. That's very clever of you.
No, I'm holding,
We're giving you a break, Maria.
So Tamara is holding one of Maria's, and Ume's holding the other one. So, and in fact, Tamara had her own baby too, and we were all sitting out at a picnic one time, and somebody came by and counted the babies and went to Tamara and said, "Where's your other one?" They thought it was the mother of twins. And she said, "I suddenly just have one, I'm sorry." So in the meantime then, I worked now with Dynamics Explorer, which is a follow-on with Atmosphere Explorer. We had two spacecraft in two orbits, one at high altitude and one at low altitude. And by measuring the aurora at high altitudes and low altitudes, we were able to really nail down that it was a parallel electric field that was accelerating electrons down at the very same time it accelerated ions up. And it was the first time this has ever been measured. And so this is one of my students, Rudy Fromm, who's now at Southwest Research. Here are a couple more of my students, Gang Liu, who's at HAO, and Loretta Weiss, who's at Los Alamos. And again, the faculty gets a little bit older, a few new faces, and a few retirees, but most people stuck around. Here's Bob Odell, who was the project scientist for Hubble, and he had some amazing things. John Weishaupt came and joined us. Hannes Vogt from Germany. In fact, Hannes was on the earlier, I think. And then in 1999, they decided, and in 2000 it happened, that we merged the department with physics and started the Rice Space Institute. The space science was always kind of intended that they were going to eventually merge with physics. It didn't have an undergraduate major. It only had graduate students. And so having although we had a SPAC option in the physics department for undergrads, but so it did make some sense to merge, although we always kind of felt like we lost a lot of our identity when that happened.
So Pat, how come it says Dr. Dunning and just Patricia Reiff?
Oh, that is, you know what's funny about that? As I said, I was, I went through the archives and looked up all the references to me. And I found where somebody had sent a letter to the editor bitching about that, saying, how come Mary got to be called doctor and Patricia didn't?
Right.
And they said that actually it was an accident. They don't normally put titles on anybody. That it wasn't that they messed me up, it's that they incorrectly gave him his title. So that was their excuse.
That was a very good excuse.
That was, yeah, that's a little weak, but that's what their excuse.
Not.
Still continuing to count electrons and protons, and still working with Jim Burch. We're all getting a little bit older. So he was the PI of NASA's first MIDEX, where we did imaging of the Earth's magnetosphere, both looking at the aurora from space and also looking at the particles trapped in the Earth's magnetic fields using this energetic neutral atom imaging that Dr. Stebbings was so instrumental in getting the statistics on. And in fact, a number of the instrument PIs for this spacecraft were Rice alum. or had been postdocs at Rice. So everybody here was a Rice person, including Carolyn, who's an adjunct, but we were there for the image launch early in the morning from Vandenberg, because it was a polar orbiting satellite. And then the most recent one is the magnetospheric multiscale one, where we spent 4 spacecraft in a tetrahedral formation, so we can unfold spatial and temporal changes in the reconnection magnetic fields at the boundaries of the magnetosphere. Again, kind of going on with the OWL satellite concept of having multiple spacecraft, so you can tell whether you just flew through something or whether something is actually changing in time. And again, everybody in this picture has a Rice connection. Dave Young was an alum, he was an alum. Here's Umbe. Roman was Tom's student, this is my student. So again, it's one still flying today, and we're still working on that data. Well, one of the things about having a relatively small department that has a relatively short history is that we were really good at getting reunions every 5 years or so. This was our 50th reunion, which is the last one we've had so lately, although we may come back and do it again. And this was a picture of everybody who had been chair of the department was in the one shot, except Bob Haymes. He was not there at that time, but Dessler and Dunning and Stebbings and Michael and Weishaupt and I were all chairs at one time, and of course Umbe the glue. And we had a really great time. We also celebrated Bill Gordon's 90th birthday at the Arecibo telescope. Of course, that has since crashed, and he has since passed away as well. Alex Dessler, we celebrated his 90th birthday with a little small consortium, and here are some of his science progeny, including Tom and Frank Tofoletto, who was another one of who was one of Tom's students. A lot of our students and faculty have gotten major awards, of course, including Alex Dessler with the Arktowski Award. And unfortunately, we've lost quite a few of our original faculty now, and some of them are still alive but not doing well. So it's you know, when they've been around for over 50 years, then you know, it's about time we lose them. And it's been a sad, special time for us recently on losing quite a few of our faculty, and even some of our students have now passed away. But it's been fun, and we've graduated 222, if you count it up to 2007, which I figure those were the last ones who came in under space physics and astronomy. We graduated 222 PhDs, of which 26 were women and 2 were Hispanics. So that was not bad for our day. A couple of
astronauts there.
Yeah, 2 different astronauts. Here's one here, and there's Shannon. Shannon just was the commander of the ISS on her last visit. So again, some really amazing students that have participated. This is Eileen Stansbury, who's the head of astromaterials at JSC. So we've got some really spectacular students that have graduated from us. And 14 astronauts have been associated with Rice in one way or the other. Some of them were actually students, some of them were adjunct faculty or faculty, but the ones that were from our actual department were Tammy Jernigan and Jim Newman and Janice Voss and Takao Doi and Shannon were actually from the space science or the space physics and astronomy department. And I think it may be telling, we haven't had any new astronauts since we merged with physics.
Yeah.
So, anyway. But we still do a lot of research. There's a lot of theoretical work, a lot of computational work. Not a lot of hardware building, which I think is a shame. But the some of the undergrads got recently selected to fly a CubeSat. So this was from their proposal. I'm sure the new picture looks a lot different, but what's the status on that?
It's doing well, but the rocket that they're supposed to go off on blew up on its first flight test, the first flight. So we're probably delayed until the fall of 22. I don't know if Doug is here, Doug Steinbeck.
Yeah, I'm right here.
He's the lead on the student project.
Cool.
So
Yeah, no official delay yet, but
they'll
things are
come.
going well.
They'll come.
Hey, rockets blowing up, that's part of, that's part
Yeah,
of.
it's better to be the one that blows up before you go.
Well, I mean, when Columbia blew up, Jim Newman was in the last successful flight of Columbia, and the next flight it blew up. So, sometimes you kind of wonder, and both the Columbia and the Challenger both put a real hiccup in space research, partially because some of them were supposed to have delivered instruments to orbit. And when they were grounded, then it hit a lot. And then, of course, just the loss of life is something that was really put a damper on space. But this week we have the first all non-NASA crew in space. And the first woman pilot who is not a NASA astronaut. So things are moving on. Well, the cool thing, I should not even mention this because it's right now still in the proposal stage, but they are talking about going back to the moon with Artemis, and there's an AO out for instruments to be put on the moon. And I was asked by some scientists at Marshall if I would be part of the proposal to put a CPLEE 2 instrument, and they're even calling it a CPLEE after the original CPLEE instrument for Charged Particle Lunar Environment Experiment. That's going to be a much better detector. It's going to be a top hat, and it's going to have better energy resolution and better spatial coverage. But it is a new generation lunar particle detector, and I think there'd be really no better ending to my career to be able to go back to the moon and count some more particles from the lunar surface. It's going to have both a fixed one and a teeny tiny 6U rover. So we're talking about putting a little top hat on the edge of the rover and steer it around. So wish me luck. All right, well, we better go. I'm running over, and so it's been fun, and let's hope we have another 50 years of good space science research here.
Yeah, I really found that fascinating. I know many of the people are here, and of course, one of the reasons we're all here too is we're celebrating the birthday of our glue in the department and the new department. Umbe Cantu retired at the beginning of the summer, which was a big shock to us all. And today's her birthday, and we have to have a little celebration of her service to, well, pretty much everybody and everything, right? So anyway, thank you. There's time for some questions. I'll maybe look at the chat while Pat's answering if there's a question from the floor. Pat, there's a hand up there.
Yes, so I've prepared it, so excuse me while I just pull this up so I say it correctly here. All right, so it kind of builds on what she said a little bit ago. As we saw this week with the historical and very exciting SpaceX launch of the first 4 astronaut tourists into space, it's clear that space is becoming a place of discovery for all people. And so what do you think are the opportunities for academic institutions like Rice to develop and guide the next generation of astronauts who might not specialize in aeronautics, but who want to work in space? What subjects or specialties do you personally think will be extremely important in the next coming years?
Well, the opening of space to non-NASA is really dramatic and really important because up till now, you had to be a NASA astronaut trained, you had to go through a really severe vetting. Most people had to apply 3 or 4 times before they got selected. You had to have an advanced degree of some variety. All the pilots had to be usually military pilots, so they had real pilot training. So with the more automated systems that we have, it makes it more accessible that you don't have to have that same amount of automated, extensive pilot training, either to be a pilot or to be a scientist. And it's telling that they are doing simple experiments in this trip. It's not just a tourist trip. And now some of their experiments are on their own relationship, their own blood pressure or whatnot. But yes, I find this as being very, very exciting because it now allows space to be accessible to a whole generation of people who might not have the qualifications to be an astronaut under the NASA banner, but could be under the commercial flights. And it opens it up for everybody. The other thing that's revolutionized science is these CubeSats. So with the miniaturization of detectors and the miniaturization of the electronics, we can pack a lot of data, a lot of instrumentation in 10 by 10 by 10 centimeters. And so the ISS, for example, takes up racks of CubeSats and dumps them into space. And this now gives us an opportunity to do these on these commercial flights as well. So I think it really opens it up. And that was the decision that was consciously made a few years back when they said NASA's not going to do low Earth launches anymore. NASA's going to concentrate on Moon and Mars and the outer solar system unmanned, and the manned to Moon and Mars, and let the commercial take up the launches to low Earth. And it caused a lot of consternation at the time because a lot of people lost their jobs. But a lot of new people are in the business now. And I see that as an extremely exciting situation.
And I think one of the transitions is where we switch from unmanned to uncrewed.
Yeah.
Right? And so that whole dynamic has changed as well. So.
Well, I believe in man being human, but I agree. I have to be careful.
As a woman leader in space, you're allowed to have any opinion on that. So.
Yes, crew.
Crewed, yeah. So we're basically getting some thanks from the audience, and there's some names that you saw on screen who are actually here listening to Pat's talk. But we still have time if there's a question or two about, right at the back, if you could speak up, and maybe if you repeat the question for the audience online.
Dr. Reiff, as you know, I've been a proud member of the Reiff Space Institute for many, many years, and I just want to thank you from the bottom of my heart for allowing me to be a part of your wonderful organization. I've attended lectures from you over the years, and it's just been an extraordinarily wonderful experience for me. And your leadership, your graciousness, the team you surround yourself with, the famous Umbe. Also, I want to thank you for your choice of Sir Alexander, who has taken your reins, and he's never kicked me out.
I've tried.
Sure. I've attended lectures from him on his solar work, his helio work, and it's been just amazing. So I just sincerely want to thank you for letting someone, a layperson like me, open up my whole mind to all of the wonders that you and the Reiff Space Institute represent. And I know that you are going to continue to contribute in a huge, huge way for the future for many, many years to come. Thank you.
list, the RSI list and the RSI Associates list. And the Associates list is for anybody who's interested in space, who wants to come to any of these talks. If you're not already on the list, let me know and we'll put you on. We are having our first open house for the observatory. We're going to reopen after a year and a half, October 16th for Observe the Moon Night. And I'll be there. So Saturday night on October 16th, and if you're a member of the RSI or RSI Associates email list, you'll get an invitation. It'll be in events.rice.edu also.
And thanks, Jim. And I think the other thing that raises, and Pat didn't really have much time to talk about it, is because you focused on the science. But the science communication is critical and key. And Pat's awards is a testament to the work that she has done in that area, and bringing everybody from the public to students, to young people, all the way through to graduate students into the field and into this understanding of space in general. And I think, you know, that's a hard thing to do when you're doing a day job of science and teaching and so on. And so there's very few people who've done as much as Pat has over the course of her career in that area as well. So I appreciate you pointing that out, because again, there's not enough time to talk about everything, and so that's worth mentioning as well. So thank you, Jim. I'm not seeing anything from online. I'm not seeing any other hands in the audience. So with that, I'm glad we were able to get, in fact, we get more people in the room than I was expecting, which is great. So thank you all for coming out. Thank you for being online. It was a great start to our next academic season. October 21, there's the open night on the 16th. October 21 is our next spaceport lecture, which will be in Keck Hall, which is just across the way there. And hopefully we'll see you there. And other than that, continue to keep safe and enjoy the rest of the evening, what's left of it. So thank you all.